In this module, we will be studying about the addition of vectors. Now, consider two free vectors, a and b. To add the given vectors a and b, we shift one of the vectors without changing its magnitude and direction, such that its initial point coincides with the terminal point of the other vector. Let vectors a and b be represented by the vectors ab and bc respectively. By joining a and c, we get triangle ABC. Now, by the triangle law of vector addition, vector AC represents the sum of vector AB and vector BC. Observe that the terminal point of vector AB and initial point of vector BC are the same. Upon adding vectors AB and BC, the result in vector is AC, whose initial point is A and terminal point is C. Let us reverse the direction of vector AC to get vector CA. The net displacement in moving from points A to B, B to C, and C to A is represented by vector AA, whose initial and terminal points both lie at point A. Thus, the sum of the vectors representing the three sides of a triangle in order is a zero vector. Now let us draw a vector BC dash that is equal in magnitude but opposite in direction to vector BC. Thus, vector BC dash is equal to minus of vector BC. In triangle ABC dash, vector AC dash is equal to the sum of the vectors AB and BC dash. We know that vector BC dash is equal to negative of vector BC. Substituting the values of vector AB and BC, we find that vectors AC dash is equal to vector A minus vector B. Consider a man at point O on the left bank of a river. The man starts swimming towards point A on the right bank of the river in a direction perpendicular to the flow of the river, with the velocity represented by vector A. The man is also acted upon by the velocity of the water flowing in the river under the influence of the two velocities. The man actually moves at an angle to line OA and reaches the right bank at point C. Let vector AC be equal to vector B. The velocity with which the man swims from point O to point C is the sum of velocities of vectors A and B. Complete the parallelogram OACB. Since OACB is a parallelogram, vector OB is equal to vector AC. Therefore, vector OB is equal to vector B. We observe that the sum of vectors OA and OB is represented by the diagonal of the parallelogram, passing through the common point of vectors OA and OB, that is, point O. The parallelogram law of vector addition states that the sum of two vectors representing adjacent sides of a parallelogram is given by the diagonal of the parallelogram, passing through the common point of the two adjacent sides. Thus, by the parallelogram of law of vector addition, vector OA plus vector OB is equal to vector OC. The opposite sides of a parallelogram are equal and parallel. Thus, vector AC is equal to vector OB. Using the triangle law of vector addition, From triangle OAC we get vector OA plus vector AC is equal to vector OC. Thus we see that the triangle and parallelogram laws of vector addition are equivalent to each other. Now let us prove that vector addition is commutative. Let us consider two vectors A and B. Consider two adjacent sides AB and BC of a parallelogram ABCD, representing vectors A and B respectively. By the triangle law of vector addition, vector AB plus vector BC is equal to vector AC, which is vector A plus vector B. Since the opposite sides of a parallelogram are equal and parallel, vector AD is equal to vector BC and vector DC is equal to vector AB. Applying the triangle law of vector addition, the triangle ADC, vector AC is equal to vector AD plus vector DC, which is equal to vector B plus vector A. Thus we find that vector A plus vector B is equal to vector B plus vector A. Hence, vector addition is commutative. If we add a zero vector to any vector, the vector remains unchanged. Hence, a zero vector is called the additive identity of vector addition. Now let us prove that vector addition is associative. Consider three vectors AB, BC and CD representing vectors A, B and C respectively. By the triangle law of vector addition, the sum of vectors AB and BC is equal to vector AC, which is equal to vector A plus vector B. Now, consider triangle ACD. The sum of vectors AC and CD is equal to vector AD, or the sum of vectors A and B plus vector C. Now let us add the vectors in a different way. Consider triangle BCD. By the triangle law of vector addition, the sum of vectors BC and CD is equal to vector BD, which is vector B plus vector C. Now, consider triangle ABD. The sum of vectors AB and BD is equal to vector AD, or the sum of vectors B and C. Equating the value of vector AD from equations 1 and 2, it is proved that vector addition is associative.